Alright, introduction to conic sections. We've already kind of talked about the circle, but let's go ahead and show how it's constructed. All of the conic sections are formed by cones. Okay, so here's a cone. If I take this cone and I cut it parallel to the base, if I cut it parallel to the base, we get a circle. Okay, so I'll try to draw three-dimensional here a little bit. Here it's just going to kind of cut around. I'll show you a picture out of the book in a minute. So when it cuts, if I pull that top part off, it makes a circle. As we've already discussed the equation for a circle. Okay, so there you have it. We've kind of already covered this. So I drew a picture showing you where everything is at. One of the other things you need to know about a circle is the eccentricity. That is the E value. Okay, in an ellipse that is nearly circular, the ratio C to A is close to 0. Okay, and the closer this E value, this ratio C to A is, the closer it is to 1, the more oval the ellipse. Okay, so the E value for a circle, the eccentricity is 0. That is the eccentricity. Okay, all right. To learn more about eccentricity, go ahead and look on page 665 at the diagram at the top, and it talks about that ratio of C to A. That ratio C to A, that's going to be your E value. Remember, the closer this ratio is to 0, the closer it is to being a perfect circle. The closer it is to 1, the more oval the ellipse. Okay, let's take a look at the ellipse equation next. Okay, for the ellipse, we have these two general forms, or I should say standard forms, where H and K is the center. Okay, this is a horizontal ellipse. Okay, the A, the radius for A is under the X. That's going to be here. So if this was 0, 0, this would be A comma 0. And this would be negative A comma 0. It's a horizontal axis. Here the A is under the Y. We have a vertical. Okay, and so we would have a vertical axis here. To get an ellipse, we cut the cone at a slant. So it is not parallel to the circle. And this would give us our elongated oval. Okay, for hyperbola, you are going to cut straight down through one cone and through another cone. So you'll have a parabola opening down and a parabola opening up. I'll show you that picture in a moment. Now the equation for hyperbola looks something like this. Okay, so here are your two equations. Notice the difference here, the subtraction versus the addition. When adding, when they're both positive, we have an ellipse. When we have a positive and a negative, we have a hyperbola. And then finally, we have our parabola. And so for the parabola, our equation is going to look like this. Now notice this is a y squared. Okay, so this is going to be like a parabola that's going to be opening to the right and to the left. That's called a horizontal axis. Or we could have and that's going to be a parabola opening up or down with a horizontal axis. Sorry, I said that wrong. A vertical axis, horizontal axis. And to get your parabola, we're going to cut our cone parallel to one of the sides. So if I cut it parallel to this side, and I try to do a parallel line here, not very good at it, and that's going to get us our parabola. Let's take it in your books on page 649. Here are your slices: circle, ellipse at a slant, parabola cut parallel to the other side, and then your hyperbola. Okay, and that's perpendicular to the base. Okay, we will go into these deeper as we go through each conic section. See you guys tomorrow.